So that's what happens here. Okay. Good. Let's try this. I mean, for this one, we're revisiting it, right? I mean, we know what the graph already looks like, as you can see. We know what the graph already looks like, okay? Y equals 2x minus 1, we drew it already. But here, I'm going to demonstrate how you find those intercepts. Okay, so for the y-intercept, right, you set x to be 0, okay? Right, the other variable is 0. And what you do is you calculate y. Right, so if you set x to be 0, what's the resulting y? Y is going to be 0 minus 1, which is minus 1. That's what we get. For the x-intercept, right? Same idea. You set the other variable, y in this case, to be 0, and you have to figure out what x is. So we have this equation to solve. Where are we now? Section 1.1 again. Okay, so let's do that. So what do we do here? We're going to add 1 to each side, right, as you can see. Because remember, for this, you want to get x all alone. Doing so, we get 2 times x equal 1 equals 2 times x, excuse me. Then we divide both sides by 2, right? Because we want to get x all alone, and we get a half equals x, so x is a half. So in other words here, right, this is telling us that the x-intercept, right, this point, in other words, has coordinates a half, comma, 0. In other words, it's passing through the x-axis at a half, comma, 0. Here, from the y-intercept, you can see we get negative 1. In other words, this point has coordinates 0, comma, negative 1. Okay, that's good. That wasn't too bad. Yeah. Okay, good. So that's one example. Well, let's do another one. So for this one, we have y equals 3x plus 4. I mean, the graph is on the right. And from the graph, you can already see that 4 is the y-intercept, right? That's where the graph touches the y-axis, or passes through it in this case, at 4. Okay? Good. When x is, okay, so how do we get that algebraically? Again, you set x to be 0. And when you set x to be 0, right, you get y is equal to 0 plus 4, which is 4. You know, you just solve for y, in other words. For the x-intercept, same idea. We set y to be 0 and figure out what x is. So we get 0 equals 3x plus 4, as you can see. So that's what we get here, right? And what do? We solve for x. We got to figure out what x is. Okay, so we got to isolate it. That is, we got to get x all alone. Subtract 4, right? We have negative 4 is 3x. Divide both sides by 3. Okay, we get x on the right side, negative 4/3 on the left. I mean, negative 4 is on top, as you can see, but that's the same thing as this. So we get negative 4/3 equals x. Hence, x equals minus 4/3. So that's what this number is. It's passing through negative 4/3 on the x-axis. In other words, the coordinates of this point is negative 4/3, comma, 0. Are there any questions about this? let's keep going then. Here's our friend, the square root of x. We have y equals the square root of x, right? So in this case, okay, right? In this case, what we have is y equals the square root of x. We want to know what the x and y intercepts are. I mean, you could solve for it algebraically. With the graph here, notice that the graph only touches the axis, both of them actually, at the origin. At the origin. So because of that, the only x-intercept is 0, and the only y-intercept is 0. Because again, it touches the x and y axis only at the origin. Everywhere it's, it doesn't touch it anywhere. It doesn't go through the axes anywhere else. So that's what happens with our square root, which is good. Now we get to parabola, the parabola. Namely, if we have an equation like this, you have y equals a polynomial of degree 2, ax squared plus bx plus c, right? Here, though, a, b, and c are numbers, but a cannot be 0. A, b, and c are numbers here, but they're not 0. The graph of this is a parabola. No matter what a, b, and c are, as long as a is not 0. I know you might be thinking, wait a minute, that's going to give us a lot of different graphs. Well, yes, but they're all going to look very similar to the graph of y equals x squared, which we'll get to shortly. Okay, so they're all going to look very similar to the graph of y equals x squared. I mean, some of them might be, well, you'll see what I mean. But no matter what a, b, and c are, as long as a is not 0, the graph of this is called a parabola. We have what's called, and to find the intercept, so for instance, to find the x-intercepts, right? If we set y to be 0, we're going to be solving this equation. So what section are we now back in? 1.2. You solve quadratic equations, right? You can solve them by factoring or the quadratic formula. Right? And unless I tell you to use a certain method, you can use either one of those two. For the y-intercept, that's a little bit easier. You just replace x by 0. And you actually just get the constant term c. So for the x-intercepts here, we're going to use what we learned in 1.2. Although factoring we learned earlier than that, so we're going to use, I guess, before 1.2 as well. For the y-intercept, you just replace x by 0. Okay, well, let's look at the graph of y equals x squared. I mean, we will see better ways of graphing these in chapter 3. But for now, let's just do this. We just plot a bunch of points. So we have to take some x values. So I chose these kind of randomly, right? And what do? We replace, in each case, we calculate y from the equation, as you can see. And once you get the y, you form the ordered pairs. I labeled these points as A, B, and C, okay, just for fun. But once you plot those points, as you can see, this is the graph we would get. You plot the points and you connect the dots, as you can see, like so. So we have -2, -2 squared is 4. We have -1, you square that, you get 1. You get -2, 4, -1, 1. When x is 0, 0 squared is 0. So we get this point. We get when x is 1, 1 squared is 1. We get 1, 1. When x is 2, 2 squared is 4. We get 2, 4. Okay, that's awesome. So we have the graph of y equals x squared. Notice that it passes through, it only intersects the y and x axis at the origin. So in other words, 0 is the only x-intercept, and 0 is the only y-intercept.